At the end of last year, I started work on a platformer game that had a lot of potential. It was going to have sprawling levels, each with a distinct and unique theme. Development was steady until I suddenly had to stop working on it. Why? Because after several months of work, I hadn't achieved the quality I was hoping for, and if I were to continue, it would probably take another year to finish. Frankly, I just think the game was too ambitious for my level of experience, so I decided to make the difficult decision to stop working on the game. Instead, I chose to use that time to finish a smaller project. Ultimately, if I could practice finishing a project on a smaller scale, I could be more prepared for when I make another large game in the future. Okay, so that's all well and good, but then what went wrong with the last game? It was supposed to have a short development cycle, but for some reason that didn't work out. Well, it's sort of obvious in hindsight. The game had 6 levels, and when you multiply that by 8 or so unique enemies for each level, diverse sets of environments, boss battles, and any other additional mechanics, it becomes clear just how large of a game it actually was. I suppose I just thought that 6 levels doesn't sound like a lot, so once I got the main mechanics down, everything else would fall into place quickly. I didn't consider how much work was necessary for each individual feature. Where the game succeeded is that it was actually a really good learning experience, from art to design and yes, even planning. Consequently, I knew to design every aspect of the next game specifically to be achievable in a short amount of time. I decided that the game would be a platformer, which allows me to reuse a lot of parts from the previous game. I also designed the graphics to only use 5 different brightness values at a time, meaning the sprites would be easier to make. I realized that I could overlay different colors on these sprites to easily add visual variety and give the game an interesting art style. I designed the levels to be short and focused, removing the need for unnecessary mechanics like checkpoints and interconnected layouts. They would also be difficult, giving each level more longevity. You probably get the point by now. The game was designed to get the most out of every hour of development time. And that is the origin of my newest game, Living Hydra. So, I guess I could talk about the development process now. I first set up everything to get the game running, but it actually didn't work the first time because I forgot to update the runtime environment. Already off to a great start. Of course, I solved that quickly, and then added all the basics you'd expect in a platformer, like the collisions and movement. I even started to set up the title screen. Like I said before, I reused a lot of code from my previous game, which helped to make the implementation much quicker, though I also spent a bit of time cleaning up the code to make it simpler and better suited to this game. So far, everything was going great, and over the next few days I would gradually build the skeleton of this game. I created a font, improved the main menu, implemented a camera, added a level select, and created that all-important screen tint. The screen tint is a very simple effect. All it does is multiply each pixel by a certain color. Since every sprite is in grayscale, it inherits the color perfectly, but keeps its brightness, which leaves the bright pixels bright and the dark pixels dark. The only problem with this system is that certain colors naturally appear brighter than others, so the brightest blue will always appear darker than the brightest yellow. This could make some levels difficult to see, and while it can be somewhat annoying, over time I found that it wasn't as big of an issue as I originally thought it might be. One way I changed my work habits for this game is that I allocated myself 4 hours every day to work on it. Sometimes I'd work a bit less, and other times a bit more, but this was mainly done to keep track of time and ensure I work consistently, so that I can prevent myself from underworking or overworking. I also decided to only work on the devlog after I finished the game, so that I could put all of my focus on the game itself. After I set up much of the mechanics, I began work on one aspect of the game that really worried me: the obstacles and level elements. Unlike with the previous game, I decided to make them all at the same time, so that I knew in advance what tools I had to work with when designing the levels. Last time, designing enemies was one of the things I really struggled with, so I wanted to get it right this time. Before coding, I started by writing down anything I could think of. For the obstacles, I thought of some pretty obvious ideas, like spikes and turrets, but I tried to think of some more odd ideas, such as jumpers which jump when the player jumps, and bubblers which emit projectiles that descend slowly, like bubbles. My goal was to have each obstacle change the way you think about movement through the levels, and I think most of these ideas succeeded in that. An important note about this game is that you don't have any way to attack enemies, you can only avoid them. You also die immediately as soon as you take damage. That might sound kind of cruel, but the benefit is that you only have a limited number of ways to tackle challenges, meaning it's easier to analyze a situation and determine how to proceed. To counterbalance this simplicity, I decided early on to add a double jump, which provides more options when moving through the air. Some of the other obstacles include circles, which move in a circle, barrels which explode when damaged, lasers that periodically activate, sparks that travel around walls, lights that shoot projectiles in all directions, movers that move up or down when passed by the player, and light bars which rotate around a point. As for the other level elements, they generally work by changing the level layout or modifying the player's ability to move. These include the bars, which dissolve when stood on, the paper blocks which are destroyed when damaged, the treadmills which change the player's movement speed, the trampolines which force the player to jump, the jump boosts which allow the player to jump again in the air, the doors which are opened by pressing buttons, and projectile barriers which destroy projectiles. As far as I was aware, this seemed to be a fairly exhaustive list of obstacles and level elements, and it seemed to be a good foundation to build a game upon. There's just one problem: I actually had to implement them, and I had no idea just how long that would take. But at the very least, I had the ideas written down. And so, after my preparations, I began work on that exhaustive list, hoping that it would be mostly straightforward. Naturally, I started with the easiest objects first, like the spikes and turrets, as well as the treadmills, trampolines, and jump boosts. With the exception of the turret, which itself has very simple behaviors, the objects don't do anything besides change the state of the player, and were therefore very easy to implement. If anything, I probably spent more time drawing the sprites for these objects. About those sprites, by the way, one of the first I finished was the treadmill, and I was surprised to find how much detail you can add to an image with only 4 brightness values. I suppose I shouldn't be too surprised, since I tend to work with smaller numbers of colors, but I guess I underestimated monochromatic graphics. Moving on to the next set of objects, the situation gets much more interesting. I started with the spark, and it quickly became apparent that its movement pattern is much more complex than it seems, because not only does it have to move around the level, but it needs to be aware of its surroundings and determine a path to take based on where it's already going. After a lot of effort, the system I ended up with works like this. When the spark is created, it connects to a wall. It then begins to move clockwise around the wall. This continues until the spark either hits a different wall or moves past a corner. It's then moved back to the edge and turns either left or right depending on what happened. It now continues moving in its new direction and the cycle repeats. Okay, so it wasn't too, what happened here? Well, after searching for a while, apparently I forgot a set of parentheses. Ouch. Nevertheless, after finishing that challenge, I moved on to other obstacles, like the laser, light, and circle. They all work by doing one action periodically, and conveniently those things are actually quite simple to program. One crucial detail is that these cycles are based off of a global timer, which is reset every time you start a level, ensuring every playthrough has the same cycle. The other objects were no more complicated actually. I mean, I guess it makes sense. They all do one simple thing, and once it's implemented, the work is done. Plus, there's not many objects in this game that have complicated movement patterns. I remember this being a big concern with my last project, where you have to worry about if enemies should walk off edges, how far they should continue to chase the player, if they should retain momentum when hitting walls, and much more. In total, it took me exactly 3 days to finish all of the level elements, and it was surprisingly painless. I genuinely thought it would be much more of a struggle, but I suppose that goes to show how simple differences between games can result in wildly different challenges when implementing their mechanics. At this point, I was just starting day 7, and while I was starting to feel exhausted, development seemed to be going perfectly. I was very motivated to finally begin working on the level design, which is by far the largest component of this game. However, that's something I'll discuss in more detail next time. Until then, thanks for watching. Bye.